What happens when a humble 1960s sedan engine is force-fed to 4-digit power and let loose on circuits built for half that speed? In the mid-1980s, BMW's M12/13 turned Formula One into a knife-edge experiment. Drivers called its boost a light switch. Marshals watched flames lick from exhausts. Fans saw a tiny 4-cylinder rewrite physics and the rulebook. This is the story of why the deadliest BMW was also its most brilliant. Deadly by context, not by body count. Deadly here doesn't mean the engine tallied fatalities. It describes an era when power outran protection and demanded superhuman timing. Early 1980s, Formula One still raced between narrow guardrails, with limited runoffs and safety measures that lagged the speeds cars were suddenly reaching. Into that environment came the turbo boom, doubling effective horsepower in just a few seasons. On long straights like Monza, speed traps cleared the 350 km/h neighborhood, while the grip, braking stability, and barrier technology were playing catch-up. The M12/13 amplified that gap by delivering thrust late and violently. Its single large turbo took time to spool, and when it did, torque arrived in a lump that could overwhelm rear tires between apex and exit. Drivers talked about planning a corner 2 seconds in advance, rolling the throttle before sighting the straight, so the surge would land where the car was reasonably straight. Miss the timing by a few meters, and the rear stepped out as if a trapdoor had opened. The label "deadly" captured that hair-trigger reality and the era's risk budget. It also reflected how the car forced the human to manage danger in real time. Teams fitted cockpit boost dials because the usable power window was so wide that drivers themselves had to ration it, turning it down to save fuel and components over a distance, then spiking it for a single lap when grid position mattered most. The engine therefore redefined racecraft. Judgment and anticipation became survival tools as essential as helmets and belts, and a driver's right hand on the boost knob could be as decisive as his right foot. From M10 iron to M12/13 thunder, BMW didn't begin with a bespoke Grand Prix foundation. It began with the M10, a cast-iron inline-4 developed for the Neue Klasse road cars in the early 1960s, a block chosen not for glamour, but for dimensional stability and toughness. In the 1970s, that architecture was honed into the M12/7 for Formula 2, where 4-valve heads, aggressive breathing, and dry sump oiling taught Munich's race shop how to keep a small 4 alive above 9,000 RPM. When Renault's turbo experiments proved the concept in F1, Paul Roche aimed BMW at the 1.5-liter limit with an over-square, high-revving derivative. The result, M12/13, kept the sturdy iron base, but paired it with a light alloy head, 4 valves per cylinder, gear-driven camshafts, forged pistons, and titanium rods. One big Kuhn-Le-Kopp Kausch compressor and an air-to-air intercooler handled the airflow. In race trim, it lived in the approximately 600 to 900 horsepower window across the era, depending on fuel and boost rules. In qualifying, engineers wound it into the 1,200 to 1,400 plus horsepower bracket by period estimates, figures the factory test equipment couldn't conclusively measure because the dynamometer maxed out before the engine did. The story that engineers used over 100,000-kilometer road car blocks left outdoors to season still circulates, mainly because it flatters the M10's legendary durability. In reality, BMW built its racing engines from fresh castings and artificially aged them, heat treating to relieve stress. A one-off experiment with a high-mileage block failed almost immediately on the dyno. What mattered was that the simple, stiff architecture tolerated pressures unimaginable when it powered humble family sedans. Refined with modern fueling and boost control, it evolved into a championship-winning F1 turbo, an engineering straight line from grocery runs to grid slots. Fire, fuel, and the switch. The turbo fire in our title isn't hype. It names a phenomenon every trackside fan could see. In qualifying, the M12/13 ran deliberately rich mixtures and heavily retarded ignition to stave off knock at boost levels bordering on absurd. That strategy dumped heat into the exhaust instead of the pistons. Unburned hydrocarbons met glowing headers and turbine housings and ignited on the overrun, spitting blue-orange spears from the tailpipes. The fuel wasn't literal rocket propellant, despite the nickname. It was exotic racing gasoline, dominated by toluene, roughly 80% in some blends, chosen because its knock resistance allowed engineers to push boost and timing while keeping detonation just outside the danger zone. Electronic injection, refined boost mapping, and careful spark control turned the four-cylinder into a binary device the driver commanded by dial. Below threshold, it loafed across the apex in lag. Beyond threshold, it detonated down the straight with a shove that felt like someone had flipped a wall switch. Choosing a single turbo on an inline-4 helped packaging and cooling. One intercooler and smaller radiators meant lower frontal drag and more freedom to sculpt side pods. The trade was the lag's length and the brutality of its end. When period drivers described the surge as a light switch, they were translating a calibration philosophy into metaphor. A 1.5-liter engine, happiest either idling on a whiff of throttle or exploding in a geyser of fire the instant its compressor crossed a critical speed. That visual drama, flames on the overrun, sparks in the dark, was not spectacle for its own sake. It was the exhaust note of a combustion strategy built to survive extremes. One-lap grenade versus Sunday survivor. The M12/13 lived two completely different lives, depending on the day of the week. In race trim, it was a distance runner tuned to survive quotas on fuel and the thermal punishment of full-length Grands Prix. As governing bodies ratcheted fuel allocations and capped boost, crews learned to lift and coast, and to wind back the dial to live within consumption targets. In that conservative window, mid-race output lived roughly between 600 and 800 horsepower early in the turbo era, rising as metallurgy, oils, and mapping improved. Saturday rewrote the rules. For qualifying, mechanics pinned wastegates, prepared volatile fuel, trimmed ignition to survive for minutes, and sent a fresh grenade engine for one or two flyers. Paul Roche's deadpan line, "It must have been 1,400 bhp. The dyno stopped at 1,280, became the era's haiku because it captured both the absurdity of the number and the limits of the instruments. The procedure around those laps made modern pit lanes look sedate. Crews swapped engines between sessions as casually as changing wings, listened for the telltale acoustic signature of pre-ignition, and staged tires that would tolerate only a lap or two before blistering under the torque. Drivers left the garage, did an outlap to build heat, delivered a single flyer, and pitted before temperatures ran away, sometimes with a thin veil of flames in the mirrors on the cooldown. If it sounds like a different sport, it was. The BMW was the superstar of that discipline because its peak was outrageous, and qualifying rewarded outrage without requiring longevity. The race that followed was another world. The knob turned back, the mixture cooled, and consumption managed. The same car became a study in restraint. The 1983 package, why the BT52 worked. BMW's turbo didn't win a title on its own. Gordon Murray's BT52 converted potential into points by treating engine, aero, and cooling as a single loop. When flat floor rules killed sliding skirt ground effect for 1983, most teams were left with holes where downforce used to live. Murray's response, executed in frantic winter weeks, was to move mass rearward, emphasize traction at corner exit, and sharpen the car into an aero. The inline-4's lower frictional losses and waste heat allowed smaller radiators and skinnier side pods than rival twin-turbo V6 packages. The reduced frontal area bought straight-line speed and protected tire life during long pulls. The transaxle and rear suspension were fortified to survive the torque spikes that arrived when the turbo hit, and the cooling architecture ensured the engine could be run hard enough to win without cooking itself midway through stints. Nelson Piquet used that package to become the first champion in a turbo car, winning in Brazil, Italy, and Europe, outscoring Alain Prost by 2 points. And he did it by exploiting the BT52's knack for exit traction, not just by surfing qualifying fireworks. The blueprint, therefore, wasn't add power, it was add system. Reduce radiator size, and you reduce drag. Reduce drag, and you raise terminal speed. Raise terminal speed, and you shorten the time spent in the most thermally punishing zones. Shorten that time, and you can trim fuel and boost to preserve the parts that must last. The BT52 looked like a dart because its design turned engine virtues into aero advantages, and it won because the car's structure, cooling, and boost strategy were drawn from one page, not three. Pushing the edge. Benetton's 1986 B186. The same basic engine showed its other personality under a different philosophy. Benetton's B186 didn't chase extreme low-line packaging like Brabham's later BT55. It gave the engine room to breathe, a robust cooling circuit, and a conventional platform that was stiff enough to absorb the torque without flexing itself to death. With BMW's uprated EM12/13/1, qualifying became weaponized spectacle. One-lap boosts, flirting with the celebrated approximately 1,400 horsepower claims, and speed traps at the high-speed temples, confirming just how little air that bodywork was dragging. On street circuits, the same package could be moody. Lag punished places where throttle timing and rotation, not raw top speed, decided gaps. But on power tracks, Hockenheim, the Österreichring, Monza, the car was a missile, and in 1986, Monza's traps put turbo cars north of 350 kilometers per hour. Drivers talked about gearboxes built like anvils, and still occasionally sacrificed to the torque spikes, and about chassis tubes that needed extra reinforcement because sudden thrusts loaded them in ways normally aspirated cars never had. Inside the cockpit, survival meant accelerating before the exit, so the turbo would arrive when the wheel was straight, riding power oversteer rather than fighting it, and accepting that qualifying tires might be done after one brilliant lap. Heat management became a driver task. Watch the water and oil lights, and if either flashed, sacrifice a corner to save a piston. That routine separated opportunists from masters and explains why the M12/13's legend stands on two pillars, numbers and nerve. Its reputation as a sledgehammer among scalpels is earned, less polite than the most refined rivals, but devastating when the track suited its appetite. Pop-off valves, Megatron, and the long goodbye. The end of BMW's four-cylinder did not arrive in a blaze of broken conrods. It arrived as a change in the air itself. In 1987, the sport fitted every turbo car with a mechanical sealing, an external pop-off valve that dumped charge above a set absolute pressure. Overnight, boost became a room with a low roof. It was still possible to run hard, but not to keep climbing without consequence. Teams discovered that where you put the valve mattered almost as much as the number stamped on its cap. Plummet far from the plenum, and pressure pulses could fool the device into opening early. Mount it closer, and the valve saw truer manifold pressure and stayed shut until the intended set point. In the garage, this looked like a plumbing footnote. On a straight, it decided races. Pop-offs also changed how engines felt. A qualifying surge once shaped like a cliff became a table, hard but flat. The instant-on violence that defined one-lap runs eased into a push that drivers could meter. That sounds kinder than it was. Valves that hunted around their set point, pecked at power along the back half of a straight. Each bleed a tiny theft from terminal speed. Wastegate maps had to be rewritten so the engine and the valve did not argue in public. Fuel allocation rules tightened the vice further. The arithmetic of a stint now began with what could be spared, not what could be made. Saturday's romance, one lap, one grenade, one glory shot, survived mostly as theater. BMW formally stepped away after 1986, but the hardware refused to retire. Heine Mader's shop prepared Megatron engines for customers, and the old four learned a new trick: efficiency under a lid. Instead of chasing headline boost, engineers chased effective boost at the plenum, reshaping volumes, so pressure recovery was clean when the pop-off receded. Charge air temperature targets became the true limiter. If the air stayed dense and cool when the valve opened, the car still strode down fast circuits with purpose. Arrows and others experimented with valve placement and plumbing length until mid to late 1988, when the characteristic dip on full throttle traces finally flattened out, and the ceiling behaved like a ceiling, not a metronome. In the cockpit, technique changed again. Short shifting stopped being just a tire trick. It kept the engine away from oscillation zones where the valve might chatter. Throttle application became a smoothing tool, not just a trigger, to keep average manifold pressure as high as the rules allowed without provoking a premature dump. The irony is hard to miss. A device installed to tame excess ended up rewarding good manners. Drivers who understood how to keep the valve asleep went farther on less. Crews who learned the plumbing grammar of pop-offs, runner length, plenum volume, valve proximity, recovered performance most had written off as gone. By 1988, with the set point lowered again, the writing was on the wall. The four-cylinder's wild side could still flash in qualifying, but the sport's appetite had shifted to measured power and lower consumption. Customer teams nicked strong finishes on the right weekends, proof that the package's bones remained sound even when the ceiling dropped. The definitive ending arrived with the 1989 ban on turbos altogether, but by then, the BMW's inheritance had already moved into the rulebook and the workshops. Power would be rationed by regulation and by plumbing, not only by metallurgy. The long goodbye was not a failure. It was an education. It taught engineers to treat the intake tract as a pressure instrument, drivers to manage how power arrived instead of just how much, and teams to win back speed by cleaning the signal rather than raising the volume. The stopwatch recorded fewer fireworks. The sport, quietly, became cleverer. Afterward, lessons from a managed detonation. Call it turbo fire, if you want. The visible flame was only the billboard. The truth behind BMW's M12/13 is simpler and more instructive. It proved that a small, stiff foundation can be driven to astonishing specific outputs if everything around it is arranged to serve the combustion event. Fuel that resists knock at brutal pressure. Ignition that protects pistons without numbing response. Air paths that favor density over drama. It also proved that bandwidth beats bravado. The engine thrived when it was allowed to be two different things, a one-lap device for grid position and a distance runner for Sundays. The teams that wrote procedures for both, rather than chasing a compromise that did neither well, won. The late-era constraints don't diminish that legacy. They define it. Pop-off valves didn't simply pull numbers down. They taught the paddock to read pressure waves and to design plenums as instruments, not buckets. Fuel limits didn't just force coasting. They made efficiency a performance part and elevated boost control from superstition to strategy. Customer seasons under the Megatron name weren't footnotes. They were the proof that a concept survives when the headline is removed, that a sound architecture keeps paying out when the sport lowers the ceiling. Strip the nostalgia, and the lesson remains sharp enough for any modern rule set. Treat regulations as design space, not handcuffs. Decide in advance which failure modes you will not permit, and make the driver an active partner in the energy budget. That is why the engine still feels deadly in the only sense that matters, not as a tally, but as a standard. It killed the notion that displacement decides destiny. It killed the excuse that a customer team cannot play for titles. And it killed the idea that an old road car block cannot host a modern idea. If you need a single sentence to take into the next build sheet, it's this: power is a consequence, not a target. Arrange the chemistry and the plumbing to protect the burn. Write the maps to keep the valves honest. Give the driver control over the risk you can't automate. Then ask the stopwatch what it thinks. The flame at the tailpipe was theater. The real fire burned in the planning.